Okay, so Mecklenburg-Vorpommern, for those of you that don't know, we are located, or us, Balticnet is located in the city of Greifswald, Germany, and Mecklenburg-Vorpommern is located on the northern shore, or the northern German shore of the Baltic Sea region. Um, Today, we plan to introduce to you some of the innovation landscape of this region so you can better understand some of our strengths up here and for further collaboration and, of course, investment. Just a bit of housekeeping for today. We'll have three speakers and we'll aim to have a bit of a question and answer time at the end. If people have questions that come into their minds, throughout the presentation, please feel free to add them into the chat and I'll navigate us through them at the end as well. So, firstly, I would just like to introduce the EPIC project. So EPIC stands for Enhancing Packaging Innovation Ecosystems for Interregional Collaboration. The project brings together all parts of the packaging value chain, from machinery and materials to manufacturers and users, with a focus on the food, cosmetics, and health packaging sectors. This structure helps us understand real challenges from industry and define business cases that can lead to sustainable solutions in the field of packaging. Our consortium is made up of partners from across Europe. We have 11 organizations from 8 countries representing cluster organizations and industry. Together, the diverse partnerships allow us to share expertise across regions and sectors and to develop innovation projects that have impact at the European level. So that's a little bit about us, and let's jump straight into our speakers. So firstly, I would like to introduce Mr. Malte Zalman. So Malte is a project manager at Invest in Mecklenburg-Vorpommern GmbH, the regional economic development agency supporting inward investment and business growth in the region. He works closely with international companies and research partners to promote Mecklenburg-Vorpommern as a location for innovative industries, particularly in advanced materials, life sciences, and sustainable technologies. So, Mr. Zalman, the floor is yours.
Thanks a lot. So, good morning, everyone, and a warm welcome. A warm welcome to Mecklenburg-Vorpommern. And to let you know, I'm responsible for the industries of the packaging industry, as well as automotive and construction, just to let you know. And we can go right to the first slide. I just want to give you a short overview of Mecklenburg-Vorpommern and its packaging industry in general. Just some numbers, some facts and highlights to give you a good overview. Yeah, so as you can see, Mecklenburg-Vorpommern is the yellow spot on the map. I hope you see it. And we are, you can say it like that, we are growth champion for the last years in Germany. So we were first place regarding the GDP in 2023 with 3.1%, and we were second one in 2024 with 1.4%. And we are still stable with 2% in this year, 25, in the half year at least. And so, as you can see, we are pretty much stable in all of our industries, while we have a recession in Germany. Well, so what's significant is also that Mecklenburg-Vorpommern covers over 210% of its electricity demand from renewable energies. The unofficial number is more like 300%. So we are a very green landscape, as you can say. And we're within the very heart of Europe, as the map shows, right? We are right in the middle and located between Hamburg, Berlin. We are very close to Hamburg, Berlin, Szczecin in Poland, and Copenhagen. And I think that's also something that makes us special. So next slide, please. Yeah, and as you can see, we are well connected. You can't see the airport right now, but we have an airport in the near of Rostock. And as well, we have lots of seaports at the coast, and also lots of highway connections, as well as train connections. So we can bring you or your goods to almost anywhere in Europe fast. So we can jump right to the next slide, please. So let me give you a short overview over our packaging industry here in Mecklenburg-Vorpommern. The packaging industry is very closely linked to the regional material clusters in wood, paper, plastics, and metals. And we have approximately 894 companies with around 1,700 employees that operates in the wood, paper, or in the plastic sectors. And in these sectors, we generate over 3 billion euros the year, and it's rising. And as I told you, these special transport hubs, such as Hamburg, Berlin, Copenhagen, Szczecin, along with access to seaports and inland waterways, makes Mecklenburg-Vorpommern a strategically advantageous production location. Next slide, please. Yes, thank you. I just want to show you some of our flagships and highlights of companies, because there are so many. I just want to show you a few. And so, for example, if it comes to wood, we have the Egger Holzwerkstoffe in Wismar. It's an international wood materials manufacturer with over 11,000 employees right now worldwide. And the Wismar site produces OSB and laminate boards exported to over 90 countries, used in packaging bases, export crates, and custom applications. Another example is Smurfit Kappa in the city of Waren. It's part of the globally leading packaging group, and the Waren plant produces corrugated base paper and packaging and employs more than 1,000 staff. The company emphasizes recyclability and sustainability. Another example is Neukallis Spezialpapier. It's settled in Neukallis, and it's a traditional paper manufacturer and part of the Melitta Group as well. Operating since 1799, so with history, and the factory produces packaging paper, filter paper, and technical specialty paper. So now we have some leading manufacturers in food and beverage packaging. For example, Schurpark, Germany, in the city of Gallien, is part of the Danish Schur Group, a huge company, and it's a 28,000 square meters high-tech facility that was opened in Gallien in 2016 to produce folding cartons for the food industry. The group employs around 800 people globally. Another highlight is United Caps in Schwerin. the capital of Mecklenburg-Vorpommern, and it's active in Schwerin since 2015. And 2 production halls manufacture approximately over 2.5 billion caps annually for beverages and food products, operating on a 3-shift schedule. Another example is Schoeller Alibert, maybe you know it. Also in Schwerin, a Dutch manufacturer of reusable packaging systems. And in Schwerin, they produce long-life plastic containers, pallets, and crates for automotive, food, and pharma industries. Now we have some companies in the wood and custom packaging producer or custom packaging industry. For example, there's a highlight with Hildebrand Group, also in Schwerin. It's Europe's largest producer of wooden cable drums and packaging aids, headquartered, like I said, in Schwerin. Yeah. And for another example, there's the Schmal GmbH, a family-run business for over 60 years now, specializing in tailor-made wooden transport packaging and crates. Another company you may know is Yamaton Paper in Rostock. It's a manufacturer of 100% recyclable honeycomb cardboard packaging. Since 2018, it has operated 9,000 square meter site in Rostock with over 50 employees. And their products are exported to France, Poland, Sweden, and other countries. Some more examples, but now out of the machinery and equipment special industry. For example, we have Vario Vac in Zarentin. It's a packaging machinery company located in Zarentin since 1995, and it employs over 280 staff and exports vacuum and thermoforming machines to 69 countries. Another example is MBM Maschinenbau in Malchow. It develops conveyor systems, feeder technology, and custom machinery for packaging lines. And Panther Karton as another example in Röbel. That's a creative family business producing high-quality folding cartons, displays, and packaging components in small batches. So there are also some companies in the film and plastics processing, like APAC Verpackungen in Schwerin. They produce tailored film and cardboard packaging solutions for retail, shipping, and engineering industries. And another example, maybe you already know it, because I know that they already introduced themselves in a masterclass. It's Cell2Green. It's near Rostock in Bad Kleinen, and Cell2Green produces a recyclable, biodegradable, additive-free cellulose packaging made from renewable raw materials using an environmentally friendly process. Very interesting, very innovative. Yeah, and to give you another overview, as you can see, these are just some examples of our research and development landscape. And as you can see, we have lots of colleges and universities, like University Rostock, University Greifswald, that has their lots of different kind of programs and projects working together with companies. And we also have research and development, well-known research and development facilities like Max Planck Institute or Fraunhofer. To stay with research, for example, I just told you something about Cell to Green. So this came out of Rostock as a project, and as I told you, it was and it is the development of biodegradable cellulose film to replace plastics in packaging, and it's led by Dr. Dirk Hollmann. Another example of research and education is in Neubrandenburg, the University of Applied Sciences. And for example, the master's program in food and bioproduct technology includes elective modules on packaging and logistics, for instance, packaging technology and marketing. And to stay with universities, you can also call the University of Applied Sciences in Wismar. And the design faculty includes, for example, packaging-focused projects within the product design program. And to show you a research project, for example, that's from the facility of Fraunhofer, and it's called the Project Plant³, and it explores the use of peatland plants for eco-friendly packaging materials. And initial prototypes have already been produced in the lab, and it's taken place in Bavaria and also in Mecklenburg-Vorpommern. And to show you some networks and clusters we have here in, I just call it, in future, I call it sometimes MV for Mecklenburg-Vorpommern, MV. And for example, we have Norkuhn, that's the North German Plastics Network. And it's a cluster of 87 companies in plastics and packaging, promotes workforce development, innovation, and knowledge transfer through colloquia and collaborative formats. We also have the Timber Advisory Council, MV, an initiative by the Ministry of Environment to promote material use of original wood, including packaging and export crates. Of course, as I mentioned, Egger as a company, we have in Wismar the wood cluster, the Wismar wood cluster, one of Europe's largest wood processing centers with approximately 2,000 employees and over 2 million meters of annual volume. And for of course, the nearby port enables global export of boards, pulp, and packaging wood. Just to name a few. What's not on the paper, for another example, there are much more. And for another example, there's also a very important facility or institution and network of Plant3. But Dr. Theel is telling you about it in a few minutes. So we can jump to the next slide, please. Yeah, digitalization becomes more and more important, and for example, companies like SurePark, Yamato, and Biovac, and also United Caps use already fully automated production lines, smart machinery control, and integrated digital manufacturing. And the companies in this industry are having a very high export share rate here in Mecklenburg-Vorpommern. It's like around 50%. And just to give you two examples, Variovac imports to 69 countries and Egger exports to over 90 countries. So we have a lot of potential here in MV and still a gap we want to work on. And so our strengths are obviously that we offer an extensive packaging value chain from raw materials to design, production, and logistics. And the last years showed us that bio-based packaging research presents a very strong growth potential in the near future. And opportunities, there are still gaps here in MV remain in glass and metal packaging manufacturing, and also in large-scale packaging machinery production. So we don't have that many companies in the machinery production, and we want to work on that in future to make the chain whole. So you can say, in conclusion, Mecklenburg-Vorpommern is home to a high-performance, innovation-driven, and ecologically minded packaging industry. From cellulose research to wooden drum production, plastic processing to machinery manufacturing, that's a little bit weaker, future-ready packaging solutions are developed here in MV. We have strong clusters, modern infrastructure, and diversified SMEs and global companies that makes us a credible and attractive location for sustainable and innovative packaging investment. So just to say a few words about Invest, you can see us as a all from one hand partner. You can write, go to the next slide, please. And as a all from one hand partner, we support you and find you the best suitable site within Mecklenburg-Vorpommern, or more different options for sites if you think about expansion. And we also help you with the funding and to get a good overview over the funding possibilities. And we also support the recruitment of skilled workers for you if you think about expansion to Mecklenburg-Vorpommern. And we make the connections here. So if you need a direct way to the politics or politicians or the networks, we are the right partner at your hand, and we make things possible and connect the people. So you can jump to the last slide just to give you some context. And if you're eager, if you're curious about more information, you can connect with us, you can chat with us, and we can talk to each other about possible projects. So thank you for your attention, and thank you.
Thank you so much, Malte. We really appreciate that insightful overview of the landscape for packaging and research and development opportunities. So that's great. We will keep moving on to our next speaker, which is Christian Theel, as he's already been mentioned. Christian is the Head of Innovation Management at Plant³ at the University of Greifswald. And there he focuses on developing bio-based value chains and strengthening regional innovation ecosystems in Mecklenburg-Vorpommern. His work bridges research, industry, and policy to promote sustainable materials and circular economy solutions in the bioeconomy sector. So, Christian, please, the floor is yours.
Thank you, Glenn, for the nice introduction, and welcome to everyone. I want to introduce you to Plant3. Malte, thank you for mentioning us in your presentation. We are a bioeconomy alliance for Western Pomerania, so it's the western part of MV, as you said. And next slide, please. And our main aim is to develop strategies for the high-value refinement of plant-based raw materials in northeastern Mecklenburg, Western Pomerania. I will tell you a little bit later why we do this. It's a network, and the network currently has about 110 partners, and we are very proud that more than 50% of these partners are companies. And then we are also proud that all chambers of industry and commerce are involved in our work actively. The network is funded by the Federal Ministry of Research, Technology and Space, and we received a number of 14.2 million euro since 2019. And the whole cluster is running, or the funding of the cluster is running until the end of 2026. What did we do with the 14.2 million euro? We mainly put them into R&D projects. So we are trying to bring together academia and businesses and NGOs and partners from the society to jointly develop products and processes and services within the field of bioeconomy. Next slide, please. But what is bioeconomy? Bioeconomy is like a buzzword, and you hear it everywhere, but what is it exactly? And there are many definitions of bioeconomy. I use a very simple one. Bioeconomy uses renewable biological resources to produce goods, services, and energy in a sustainable way. It aims to replace fossil fuels, reduce waste and emissions, and balance economic growth with environmental protection and creating circular systems. So that is a very simple definition. There are many more and many longer definitions of bioeconomy. What we have excluded in our work in Plant³ is the energetical use of our biological resources, because that would be too much. Bioeconomy is broad anyway. And to make it short, it's based on biology. It's sustainable, or at least it should be sustainable. We have to monitor that constantly. It includes many sectors. So bioeconomy is not a branch. It's not a technology. It's a concept. It's a circular economy, and it drives innovation. Please go further. Yeah. So bioeconomy is highly interdisciplinary. Alone, if you take the University of Greifswald, there are 11 institutes of the university involved in our work, and that may be social sciences or geography or biotechnology or landscape ecology or whatever. So they are all involved in our work, and it's cross-sectoral. So it's, as I said, it's an economic concept and not a branch and not a technology. The consideration of sustainability is extremely important for us, because it's not naturally sustainable. What you do here can have consequences which are not foreseen in other parts of the world. So we have to guard that what we do is really sustainable in terms of economic, ecological, and social aspects, which are equally important. And it covers the primary production, and then it goes further to the refinement of biogenic raw materials in different or following different paths, like food and food additives, like material utilization and energy utilization. Then also we have a closer look at the residual material streams, and trying to aim for a cascading use of our biological resources. And at the end of this chain, we have to make sure that we have an environmentally sound disposal. So you can see it's actually a cradle-to-cradle approach, which is needed if you want to develop a bioeconomy. But why do we do this in our region? This program from our federal ministry was thematically open, and we chose bioeconomy because we see that in our region we have a high availability of land. We have lots of agricultural fields which can be used for tests and for new and innovative approaches. We have a wonderful research landscape with the University of Greifswald, Rostock, and the universities in Stralsund and Neubrandenburg, and they match. They have different competencies, and that all fits very well together, so we can make use of our research landscape. It's a good networking among the stakeholders in Mecklenburg-Vorpommern. We are a small country, and that makes it much easier to connect between the different stakeholders. And we also have clear, unique selling points. We try to use the biological resources from our agricultural land, but also from peatlands, as Malte has also mentioned in one of his slides, and also the marine resources like algae. And at least the two last one are unique selling points for our country, because we have an excellence in peatland paludiculture and also in the blue bioeconomy. But as we can see, our country is so far mainly an exporter of agricultural goods. We have the potential which comes along with this high agricultural potential is not fully exploited. So we have to see that we have more value in our country because we have an insufficient value-added depth in our country. Next slide, please. We have had a strategic development in our cluster. At first, we have seen the biological resources in land, more peatlands and the sea. But then we have seen that this is a big area, and it's like a jungle, and we have to focus a little bit more. So we ask ourselves, where do we have the biggest interest of the industry? And then we have defined our focus areas, and this is food and dietary supplements, as well as animal feed. Then also fine chemicals and phytopharmaceuticals, bioplastics and packaging, and this is what brought me here, and sustainable building materials, which is indeed very active. And in addition, we have cross-cutting topics like sustainability and social innovations and transformation of our region. Just to mention a few project examples, when it comes to the use of agricultural land and wetlands, for example, as I said, we have 29 projects running, but one of them is dealing with the certification of ecosystem services. Also, we have a project which is running about injection molded parch from cattail and cultivation and utilization of new legume varieties, and also the use of residual materials such as apple pomace as a protein source. For the use of marine resources, there is one project dealing with the special sugars from algae, from polysaccharides from algae for the chemical industry. This is a very high value. 1 gram of these sugars on the market cost about 10,000 euros. So that's a really high value that we can generate with this. A second project is dealing with Allgemeinbrot. It's called Allgemeinbrot, and that's like a word game, because Alge is the German word for algae, and Allgemein is the German word for common, for the common people. So, and Brot for bread. So it's a bread made with regional algae. And then we have a project dealing with methane reduction through the addition of red algae in feed, also with plasma-based dye extraction from microalgae. Thomas, this is made in your institute. And the coupling, this is a very interesting issue that we discuss also with Invest in Mecklenburg-Vorpommern. How can we couple hydrogen production with biorefineries, for example, for marine resources? And now I come I will highlight two of our focus areas. The first is biopolymers and packaging. And we have one very well running project with very well results about bio-based polymers from paludiculture. So we use cattail for producing films for packaging and also for injection molding parts. And the first prototypes are already existing. Of course, it's in a lab scale. And one of the biggest needs that we have is upscaling into industry, into industry standards. And another project is dealing with hemp panels instead of fiberglass in boat construction. And one of our guests today is Peter Breuer. Peter, hello. He's an expert on this, and he's also involved deeply in this project for the boat industry, for the ship industry. What we see is that we could really use or need a fiber processing facility in our region, which should be used by academia and also by the companies, and it should be used for different resources from different sources. We see that upscaling is very much needed to reach industry standards and to be more interesting for the industry. And then we see also that regulatory issues are of high interest and we have to tackle those. Next, please. And then the second, as I said, very dynamic focus field is the development of ecological building materials. And for example, we have a prototype of a single room building made from cattail. You can see that on the picture to the right, bottom right. Then we also develop load-bearing hemp construction panels, which are fully recyclable, or lightweight wall elements made from rapidly renewable raw materials. That could be straw, it could also be hemp. And also insulation materials made from dominant plant species of rewetted peatlands. So as you can see, we have a lot of projects running for the use of paludiculture resources. But why do we tackle those branches? The first is the building industry. Buildings are responsible for about 40% of the greenhouse gas emissions worldwide and also the energy consumption, as well as 50% of the raw material extraction from nature and 50% of the total waste generation. So we can see if we do something here, it has a very positive effect. And also the transformation in the construction sector alongside with the energy transition is one of the most important levers for achieving the climate targets. And then the plastic industry, packaging and biopolymers. Plastic waste burdens our environment, as you all know. So microplastic is a huge problem, and we have to shift from fossil-based plastic to recyclable and disposable biological polymers. And then we also have, and that is really a very great development, we have a huge alliance of industrial companies. It's now 17 huge companies in Germany, which have have brought together all their competencies to develop solutions for environmentally friendly packaging and also building materials. And all of these huge companies do R&D projects without any funding. They do it on their own expenses to find out whether they can use peatland materials for packaging and building materials. And Malte, you have already told one example from Fraunhofer IVV. And I can say it's not only prototypes existing, but also huge prototypes like 100,000 packaging pieces, which have recently won the German packaging prize. Next slide, please. And then the second question is, why do we focus on peatlands? In our region of Mecklenburg-Western Pomerania, we have about 12% of the land covered with peatlands, but 97 of them are drained. And these drained peatlands are a huge problem because they account for 30% of the state's greenhouse gas emissions. That is more than the whole industry in our country. So we have to re-wet them. But if we re-wet them, then the farmers should have an alternative income source. And that could be the utilization of the plants that grow there, and that is called paludiculture, with different paths that you can take for making money with this. And products from peatlands also have a multiple climate benefit. That is first a CO2 storage in raw materials. Second, we have an emission reduction through the rewetting. And third, by the substitution of energy-intensive materials made from non-renewable resources and the shift to biological resources, we can also save emissions. So that is a big motivation for us to do our research there. And why am I here? We are always looking for strong partnerships, also internationally, for companies that seek R&D or market entries in our country, Malta, as you said, but also for our companies in our network that are seeking R&D and market entries in other countries, like in the Baltic states or through the whole of Europe. And also for universities and other research organizations, they are always happy to find partners and to do joint projects. And also, we are looking always for engaged people who share our vision of a fossil-free economy based on social, ecological, and economical responsibility. Thank you for your attention, and this is our team. And please contact me if you have any questions.
Thank you very much, Christian, for your presentation and some really interesting points made there by there. And I find the paludiculture very fascinating. So great to hear more about that. We'll move straight along to our next presenter, Dr. Thomas Weihe from the Leibniz Institute for Plasma Science and Technology here in Greifswald. Of course, us being a plasma science cluster, we need to introduce someone working in our field. So Thomas Weihe is specializing in plasma-based applications for food safety and hygiene. His work explores innovative uses of plasma-treated water and air for cleaning, microbial control, and sustainable production processes in the food industry. So Thomas, please, the floor is yours.
Thank you very much for your nice introduction. Dear ladies and gentlemen, welcome to my today's talk. It's plasma-based contact surfaces, food contact surfaces, cleaning and protection in the food industry. On my first slide, I'd like to introduce you into my working group. What we are doing, we are developing plasma-based processes, indirect plasma-based processes, which are a bit opposed to direct plasma processes. Direct plasma processes are processes where a plasma source directly acting on, let's say, on a surface to alter the surface chemically or to introduce structures on the surfaces. That's not what we are doing. We are processing air or water to introduce reactive oxygen and nitrogen species, which are useful for many processes. We are able to for decontamination. For example, here we have Bacillus subtilis biofilms, which are successfully combated with plasma processed air or plasma processed water. Plasma processed air we introduced into a smoking step, but the most famous or the most best process we ever made is the cleaning of leafy greens, which already reaches industry. We have a pilot scale. We developed that in a pilot scale process, and it's the person who is responsible for that work is Dr. Ehrbeck and Uta Schnabel. We are working together in our working group, and it's the Ehrbeck-Schnabel working group. So let's go on. This is the brief overview what actually plasma is. Plasma is, let's say, the first state of matter. We have solid, we have liquid matter and gaseous matter. That's matter what we use, what we met every day. But we also have plasma. If you have a gaseous state of matter and you are also adding some energy, you're getting ionization, and you have a plasma. You have a burning plasma. And plasma can be ignited in at ambient air, and that's what we do. We have several plasma processes, and what we are giving you is a plasma process. This is ignited under normal circumstances, under the pressure and temperature and so on. Next slide, please. This is the plasma source which we are using. It's a microwave plasma source. And as I said before, we are introducing a reactive oxygen and nitrogen species into first air and afterwards into water. And the species come from the modus operandi of the plasma source. Let's say the more energy you're incorporating into the gas, the more the reactive species are shifted to the nitrogen side, and less energy, it's the oxygen side. So we can say it's a rough estimation, but you can also geometrically alter your plasma source and shift it between nitrogen and oxygen species. Next slide, please. What we are doing is introducing, I just like to talk today about plasma treated water. And what we are doing, we are first generating plasma processed air. And this air is introduced, let's say, into a bottle or into a cabin where water is, and it reacts with the water. Over the surface of the water, these reactive oxygen or nitrogen species can enter into the water, and they build up the plasma treated water. Next slide, please. We have some values about our plasma treated water, and it's a mild electrolyte. We can see it. It has 150 milliosmol per liter. It also has the reactive nitrogen species NiO3 and NO2, and it has H2O2 in a remarkable content. This is what our plasma treated water gives you. We use that water. This is our methodology. This is our process we are focused on, or which I'd like to introduce you today. It's the cleaning of conveyor belts, and we did, it's just an experiment. So we have the samples of the conveyor belts, and we cleaned it. We first decontaminated it with some apple mash and with minced meat. And we cleaned it 5 minutes with this nozzle you can see above the samples. And all of this is publicated in our paper, Reduce and Refine. You can download it for free and follow our experiments in a greater detail than today. Please, next slide. This is our results. We have two, as you can see on the slide before, we have two samples with different materials. It's polyurethane and SE. And these samples are cleaned with PTW, with water, with NO3, and without any treatment. That's what you see. And you see that the cleanings is rather as good as the best cleanings. We arrived with water, H2O2. It's almost all is gone. If you're using NO3, we see some stripes on the G. You see a stripe, which is a rather dried out salt effect or something. Every now and then it's observable on NO3 clean surfaces. PTW has a cleaning success as good as water. But up to now, I didn't give you an advantage of PTW over H2O2. So why use PTW? Next slide, please. This is the advantage. It's valid for decontamination. You can decontaminate bacteria. We are here have again this Bacillus subtilis, and we were able to clean it up to 6 log steps. And yeah, this is a quite good result. Cleaning with water just gives you up to 2 log steps. What we see here is just a mixture between PTW and brass. This is, our nozzles was made out of brass or steel. So we might have the feeling that we have a stronger contamination if you add brass or add steel to our PTW, but that was not the case. We only have, it was not really statistically significant that we have a stronger or a weaker action of the PTW. Just for, it's the treatment and the surface treatment. It's the treatment of the production of the plasma treated water, which is 1, 3 to 5 minutes, or the action on the surface of the nozzle, or the nozzle. We just, the first, you see, it's just the water runs through the nozzle. 2 hours, the nozzle was put into PTW for 2 hours, for 24 hours, for 84 hours, and you don't see any significant difference here. Please, next slide. And this is what our PTW does with our samples, and we see there's no stronger action than any other cleaner we used, like, which is tap water, purified water, or nitric acid. It's all the same, and again, it's not statistically significant. Please, next slide. But what has it all to do with packaging, or with the packaging step? In food industry, especially in food industry, because that's the field where I come from, packaging, I think it's the same in medical fields also. Packaging is a barrier which protects your goods, and we want to support that barrier, not in terms of giving you another material for a barrier protection of packaging protection. Just we want to alter or to support that barrier. And here's a very nice example what we can do, which we also do with plasma treated water, and it's published in a publication from Spain by Sans Garcia. And she treated natural cork stoppers with plasma treated water. I don't know if you're familiar with trichloroanisole. No, you are familiar, because sometimes a cork stopper can be contaminated with trichloroanisole or chloroanisole, and it gives you that adverse taste. It destroys a whole bottle of red wine. You might all discovered it before. This is that chemical, and we can make a degradation with plasma treated water, and so give you a protection for valuable foods and to stay them away from adverse flavors. So this was something more like an outlook. This is our summary. So we have 2 distinct plasma decontamination methods: indirect plasma decontamination methods, which is the use of plasma processed air and plasma treated water. Plasma processed air is chemically more reactive than PTW. So if you have a more vulnerable food or vulnerable good you want to treat, it's better to use PTW. And PPA, for example, has to used for the cleaning of reusable PET bottles. That was our starting point. So we are not so far away from packaging. Yeah, and you saw it by our electrolyte measurements. PTW, or in general, plasma-treated liquids, are mild electrolytes, which means it's only mild in terms of the treatment with the plasma source. If you have an electrolyte, if your liquids you want to plasma treat, it's already a high electrolyte. It won't destroy the electrolytes in that liquid, but it will add some more. That's what we do with our reactive oxygen and reactive nitrogen species. Yeah, and other pro is that both the PPA and the PTW can be produced on demand. We just can start the machine, and a few minutes later, we have our wished amount of PPA or PTW. And this helps to contribute to more effective wastewater management. Next slide, please. So 2 minutes to 11, I'm done with my talk, and these are important people in my working group. First of all, Professor Dr. Jürgen Kolb and Dr. Ehlbeck and Dr. Uta Schnabel, who are responsible for the acquisition, or mostly responsible for the acquisition of our project and the working group. And on the right side, you can see some people who gave out the money for our projects and who are responsible for the organization of the research here in Mecklenburg-Vorpommern. Thank you very much for your attention, and thank you very much for having me. Goodbye.
Thank you so much, Thomas. It was great to hear about some of the things that are happening at our doorstep here in Greifswald and the research that's supporting our packaging industry. So it's great. We are almost out of time, but I just want to give people the opportunity, if there is any bursting questions that anyone has to any of our speakers, feel free to ask it now. Anyone? Otherwise, if there's no questions here, people can always email us with questions, and we can forward them on to our speakers. Also, yes.
Okay. I missed the button to raise the hand.
Okay.
I have 2 small questions to Dr. Weihe.
Yeah.
One is, understand it correctly, plasma treated air can't be used to treat some goods who contains organic substances like vitamins or so on and so on, because they should normally, if you put some if I'm wrong, you are destroying also the compounds you would like to have.
Excuse me, Mr. Schwab, the connection was very weak and I didn't understand the second part of your question.
Okay.
Can you please?
Yeah, that means you can't treat goods with organic compounds with plasma treated air.
It's difficult. It's not, you can, but it's difficult. I treated, for example, eggs, and they build up sulfur hydrogen, and which was smelly after that. So you sometimes I mean, we do decontamination and we have reactive nitrogen and oxygen species, and these are not asking, are you a microbe or are you a foodstuff? They are just reacting, and so we have reactions with organic materials. You are right. It's very easily.
The second question, I think, even if you are not the expert, I just have a question regarding packaging material. As I know, you are also working a lot with coatings in the institute.
Yeah.
Are there some work running having flexible coatings like silicon-based coatings on bio-based polymers, biodegradable polymers especially, because that would be somewhere where I see a large future.
This, you're right. I shortly introduced it at the beginning of my talk. I talked about direct plasma sources, and if you want to alter a surface chemically to introduce other compounds which might be protected the way you suggested, we are doing it, but since we are switched to our indirect methods, we just, but you are right. It's a great field of future, and plasma sources are already used in the industry to alter surfaces, and why do not do it on packages? Yeah.
Okay, thank you for your question, Alexander, and for your answers, Thomas. It's great to know that there is potential to strengthen some of our barrier surfaces, our biopolymers and stuff. And so that's, I guess we'll watch that space to see what could develop in the future. I know we are slightly over time at the moment, but I really do want to thank everyone for their participation. You'll see in the chat there's some future upcoming masterclasses in the areas of packaging, in food, the health sector and cosmetics packaging. So please feel free to take a look at that. We also have a link to our YouTube channel, which you can catch all our masterclasses and all our regional innovation workshops as well. So, and of course, our LinkedIn site as well. Once again, thank you so much for everyone for joining in, and for our panelist speakers. Thank you very much for your time and your energy and everything that you've shared to us. Thanks again, everyone. And
thank you.
Thank you very much for your organization and all that.
Bye.
Thank you so much. Bye-bye.
Thank you.
Thank you, everyone.
Bye.
Thank you. Bye.
Bye.
Bye.